Oh, well, I bet. So yeah, right now, we are starting the new chapter, equations and inequalities. So basically, we're just gonna solve a bunch of problems. Yeah, this is solve for x. Right. Let's start. So for grade 10, we're doing two kinds of solve for x. There's linear equations where we will be solving linear equations, and there are quadratic ones where we are solving quadratic equations. So remember, the whole idea of solving for x is that you have an unknown variable, usually it's x, and you are trying to find all possible values for that variable, right? And usually one of the things we'll do, there are plenty of ways to actually solve for x. We will do plenty of methods, different kinds of problems. So there you will see, especially with the problem we're gonna start, sometimes you have to factorize, sometimes you may not need to factorize. You just do what, group like terms, right? So that you can subtract, add them, whatever. Let's just get done with it. Yeah. So we have, like you see here, the problem are the same, but I'm gonna use two different methods to solve them. Yeah. So say first on first, I'm gonna start with grouping like terms. By grouping like terms, it's like, okay, I take variables where they are variables, and damn, that's crazy. And I take numbers where numbers are. So to do that, I have 2 here, so I'm gonna transpose it to this side. So I'll have 1 minus 2, and then here I'm left with 2x. Then I have minus 1, 2x. Then I divide by 2 both sides, because what I'm looking for is this x. So I'm dividing by 2 both sides, and I'm getting minus 1 over 2. Right. So you see from doing what, from grouping like terms to like terms, it becomes easier now to eventually get 2x minus 1 over 2. Come on, minus 1 over 2. You see, we get 1, right? So let's come here on the second one. Say for example, I decide, I see common factors on my left hand side, so let me factorize it. So we take out 2, we are left with yeah, x plus 1. Then we divide by 2 both sides. This divides each other. We have x plus 1 equals to a half. Then we have x equals to a half minus 1 here, which is minus 1 over 2. Right, done. Yeah, let's see the next problem what we have. So here we have a bunch of terms now. The first bracket, we have a lot of numbers, so we might have to multiply the 4 into the brackets. And then we have a couple of a mixture of constants and variables whatsoever. So let's do that. I can just say we have no, that is 8x minus 36 minus 4x being equals to 4 minus 6x. Right, now I'm going to group like terms, right? Variables that side, numbers that side. So what I'd like to do is I look at where the highest I look at the coefficient, the highest coefficients of my variables now, of which this time it's 8, and 8 is on my left hand side. So I'm just gonna take 6 to the other side. So I'm gonna have 8x plus 6x minus 4x, right? And then I have 36, I take it that side. Then I have plus 36, right? 36 and 4, that is 40. Right, here I have come on, I have 2 here. I add in that, I have 10, so that is 10x. So then I divide by 10, this cancels, x equals to 4, right? X equals to 4. And also maybe just to test it, you could say 4 minus 6 times 4, we are getting minus 20 on the side. So then I go again 4, 2 times 4 minus 9, right? Then minus 4 times 4 minus 20 again, saying we are still right, né? Cool stuff, cool stuff. So let's see here. Here is another classical example where we're going to have to transpose in, right? So I'm saying, of course, 23 is the highest, you know, and it's positive also. So I'm taking 3, transpose it to the other side. You have 23x minus, it changes the sign, minus 3x equals to 6 plus 12. Then I have 18, then I have 20x, right? Yes. Then divide by 20 both sides. Then x gives me, you could either write 18 over 20, or you could go like 9 over 10, right? Yes, it is 9 over 10. Cool. Yeah, nice one. We have a beautiful example here. So for this kind of ones, né, I want to make you aware of something. You see, we had 2 here, né? And that 2 we can also write it as 2 over 1. And then from here you cross multiply. By cross multiplying, this is multiplied by this, and this is multiplied by this, right? So then you're gonna end up having 1 times that, you have 2 minus x, and then 2 times that, you have 6x plus 2. Now you start the transposing, you have 6x plus 1 x, and then, oh my goodness, what is happening here? I bet. Alright, cool. Then you transpose this guy. Yeah, you transpose this gentleman. Everything makes sense. I got confused for a second because of course here you're gonna have 0 minus 0, I mean 2 minus 2. You transpose this 2 to the other side, it becomes negative. So 2 times minus 2, 0 equals to 7x, and therefore x equals to 0. Right, so I was kind of shocked, you know. But you see that 2 minus 0 over 3 times 0 plus 1 is definitely 2 over 1, which is of course 2. Yeah. Yeah, when I picked up this example, I thought it would be like a bit challenging. Yeah, because I just pick up these examples. I don't like solve them before, like, or check. I just do everything here on the video. But yeah, let's continue. Here we have fractions, which becomes more interesting now. It becomes more interesting. Yeah, it becomes more interesting. So we're going to have to, of course, apply the laws of fractions. We want to make sure that before we add or subtract, we have the same denominators. Now, but also, I want to say this. It may not be the case here. I mean, you could. I will do it in 2 different ways then. I'll do it in 2 different ways. One way, we are going to make sure we have the same denominator. So, you know, if you want to actually get the same denominator when you have multiple fractions and your denominators are all numbers, you look for the lowest common multiple, right? So it'd be like 2, 4, 6, 8, 10, 12. Let me stop there. And then 3, 6, 9, 12, 15, 18. And then you have 4, 8, 12, 4, 8, 12, 16, 20, 24. And then you look for the what? For the lowest common multiple. So 2 only appears here, 3 only, 4 appears here and here but not here, 6 appear here but not here, 8 appear here but not here, 10 appear here only, 12 appear here. So you realize that 12 is the lowest common multiple. So now what you're gonna do is you're gonna be like, okay, you have x plus 2 over 4 over 4. So the 4 you multiply by 1 2 3, so you're gonna multiply by 3 over 3. Then you say minus x over 6 3. For 3 1 2 3 4, you multiply by 4 over 4 equals to 1 over 2. You multiply by 6 1 2 3 4 5 6, so you multiply by 6 over 6. Let me remove this. Right, then now it's your multiplication time. You have 3x plus 6 divided by 12. You have minus 4x minus 24 24 years, all over 12. You have 6 over 12. Perhaps let me transpose it, and then these two, you have 3x plus 6, then you're gonna have minus 4x plus 24, the negative, the positive, right? And then over 12 minus 6 over 12 equals to 0. So now with the numbers you have 3x 4x, so you're gonna have minus x. So let me start with the numbers because they are positive. You have, okay, you see 24 plus 6 is 13, or let me just say 6 minus 6 is 0, and therefore you have 24 minus x. Did you see it? 6 minus 6 is 0 plus 24 is 24. 3x minus 4x minus x over 12, but this whole thing is equals to 0. Then you multiply by 12 all over, multiply by 12, you have 24 minus x equals to 0, x equals to 24. Let's give it a test. So we say 24 plus 2 all over 4 minus 24 minus 6 all over 3. We are getting exactly 1 over 2, which is right half. So I'm gonna use a different method, which is the one that I actually prefer over this one. Yeah, it's a method that I actually prefer over this one that we have just done. So here, instead of trying to make the denominators the same, let's try to remove them at all. For here, if you want to remove the denominator here, you multiply by what? By 4. Right, so okay, let me say x plus 2 all over 4. If we want to get rid of this denominator, we're going to have to multiply by 4 over 4. That means here we'll multiply by 4 over 4, multiply by 4 over 4. Because remember the laws of equations, then what you do on the left, you also do on the right. Yeah. Wait. Yes. No, wait. We have the right idea, but the wrong execution. So I'm gonna remove this. So yes, we are still going to multiply. In fact, let me write this and say x plus 2, 4 minus x minus 6, 3 equals to half. Right? We are still going to multiply. But now, with the same law, what you do on the left, you do on the right. So with 4, we will multiply by 4. 4 multiply by this whole thing, because we're trying to get rid of this denominator. And then we try to get rid of this denominator as well, so we're going to have to multiply by 3 again, right? And then I mean, we are done, but you can also, yeah, we are done, because now this 4 is going to eliminate the 2 as well, right? So you see here, basically we're just multiplying by 12, but like, let's continue. So on this term, if you multiply by 4 is going to cancel out, so you just have 3 multiplied by this. You end up having 3x plus 6, ne? And then let's come here, you have a minus. Let's come here, the 3 are gonna cancel out each other, and then you end up with what? With 4x minus 6, 24, right? And then here the 2, what's gonna happen here? So you have 4 divided by 2 is 2, so 2 times you're gonna have 6 here, right? And then now we're just adding 3x plus 6 minus 4x plus 24 equals to 6. Let's transpose minus 6, we have 0. You have, this is 30 of course, and then this is minus x, then 0, maybe not minus x, let me say not 0, let me take x aside, is 224, right? we still end up with the same answer. So yeah, the mistake I almost did, and I was trying to multiply by 4 over 4 on every term, right? I mean, as long as you multiply by 4 over 4, technically it's not a mistake, because eventually you would have, no, it is a mistake. It is, okay, it's not a mistake. Multiplying by 4 over 4 is actually trying to make it, if we multiply by 4 over 4, we are making, we will be solving it like method 1, yeah, because method 1, that's when you're trying to make sure that your denominators are the same. So if you still have the over 4 as a denominator, you would still have denominators later on, but there's nothing wrong. You would get to the correct answer if you don't do any mistake along the way. Let me do number 3. So here you have, it's 3, right? Okay, I could say the same thing. I want to get rid of this 4, so what am I gonna do? I'm gonna multiply everything by 4, né? So then I end up having, that is 12 minus the 4 cancel, so I have y minus 2, then I have 16 and then I'm gonna have 12 minus y plus 2 equals to 16. Then I'm transposing the y side to be positive, and then I have these 2 together, that is 14 minus 16, and then y is equals to minus 2. We go prove it. We say 3 minus, so you have minus 2 divided by 4. The answer is 4, just like we have it there, right? Let me start with this one. So for this one, it's the same logic as the other one we had. So remember, now this is 1 over 1, and now you're going to cross multiply, right? When you cross multiply, you end up with 2a plus 6 equals to 3a minus 4, right? Yes, so now I'm gonna transpose 2a to that side, then I have 6 plus 4, we have 10, we have a, and it's done, right? Let's come this side. This is kind of beautiful. We have the same plus or minus the same example as that side, that other time. So this is just a, it's not 9, a, and this also is a. So you see here, if we try to find the highest common denominator, the lowest common multiple of our denominators is going to be 6. Yeah, it's going to be 6, right? So I'm gonna be like 5 over 2a multiplied by 3 over 3 then plus 1 over 6a, I leave it like that, minus 3 over a times 6 over 6 equals to 2 times, then here I'm going to say 3a over 3a. No, 3a doesn't make it, it's 6a over 6a, because I need that divided by 6a, né? So then you have 15 over 6a plus 1 over 6a minus 18 over 6a minus, now I'm taking this one to the side, and I have 12 here, minus 12a over 6a. And then I have 0 this side. So now if I add the numbers, I have 15 plus 1 minus 18. So 15 plus 1 minus 18, we have minus 2, and then we have minus 12a over 6a equals to 0. Multiply by 6a both sides. We end up with minus 2 minus 12a equals to 0. Therefore, minus 2 equals to 12a divided by 12, and then a equals to minus 1 over 6, right? To verify the answer, I come here, 2 into negative 1 over 6 plus 1 over 6 into 1 over 6. It's a negative, I forgot the negative. Minus 3 over minus 1 over 6. You see, we get exactly 2, right? Just saying that, hey, look, whatever you've been doing is correct, you have the right answer. Yeah, cool. Yeah, so let me end this video here, and then on the next one we will solve quadratic equations.